This is related to probability. Probability, all the things that you should know is what is an event, outcome, sample space, meaning of and or not, complement, everything that you're seeing on the screen. These are the things that you should know. Are you with me? Apart from this, when you are talking about drawing a Venn diagram, so there are 8 essential Venn diagram which I feel you should definitely know. Apart from these 8, there are more which we will practice. Before that, come on, tell me what is an experiment?
Experiment is when you run multiple tests to get an outcome.
Okay, when you do something on a very repeated basis is an experiment. Can you give me examples of experiment?
Uh, Tossing a coin.
Tossing a coin. So when I am tossing a coin, that is an experiment. But what will be the outcome?
Heads or tails.
Heads or tail? What is a sample space?
Sample space is the outcomes you can get.
So sample space would be a list of all the outcomes. Now, when I'm talking about tossing a coin, head or tail is my outcome, and only that is my sample space. But when I toss 2 coins, my sample space would be something else. When I toss 3 coins, my sample space would be something else. Are you with me?
Yeah.
If I'm tossing 2 dices together, my sample space would have how many outcomes?
4
12.
outcomes. You're tossing a coin 2 times, right?
I'm tossing
Oh, a coin.
a dice 2 times.
That's so
A
12.
dice 12, yeah.
Okay, so when I'm tossing a dice 2 times, my sample space would have 36 outcomes.
Yes.
Please see this. Come on, what is an experiment? What is an experiment?
Experiment.
Hmm.
Experiment is something that you do multiple times to get an outcome.
Experiment is something that you do multiple times. What is an outcome? When we talk about an event, event would be the collection of the outcome. So I have experiment, outcome, sample space, and event. Are you with me? What do you mean by
Yeah.
and?
Multiply.
And what else do you mean by and?
And is
A union
A union
B.
B.
And means both the things happen together.
Yeah.
It will not be union. When I'm talking about and, both the things are happening together. So it is
And is the intersection.
and is the intersection.
Yeah.
When I'm talking about or, that means either full A can happen or full B can happen, A or B. A or B is like a marriage. Or, what do you mean by or?
Or is union.
Or is union, it means either or both.
Yeah.
And is intersection. Intersection means both the things happening together. Okay. Or means either or both. Either means either A or B or both. Or is union, union is marriage. When I talk about not,
Means everything except for not the
yeah, so
thing.
not is also called complement. So if you see over here, what is highlighted over here?
Not
Not
A.
A.
Not A. So it is also called complement of A.
Yeah.
How do you find probability of not A?
1 minus.
1 minus probability of A.
1 minus
Yeah.
probability of A. So these are the things. Now, when I'm talking about probability, what does it mean? What does it mean?
It means the
Likely chances.
probability. Yeah.
It means
Likely chances
chances
of getting
of
outcome.
something happening. Okay, it means chances of something happening. So if I'm talking about probability of A, what is the formula to get the probability?
Formula of A would be favorable outcomes divided by total outcomes.
Favorable outcome divided by total outcome. If you remember something about conditional probability, so there is probability of A given that B has already happened.
Means that you
My
will only take the intersection of
Hmm.
A and B divided by the probability of B.
See, I have two circles, okay? A and B. I want to find probability of A given that B has already happened. So my total
Yeah,
outcome would now become the probability of B.
yes.
And I want probability of A, that means I am looking at this part now.
So you're gonna use the intersection of
So
A
I have to
intersection.
use the probability of A intersection B. Please remember these events are not independent. There is a difference between an independent event and a mutually exclusive event. Before I go on that, there are these 8 Venn diagrams which I want you to know particularly. So you all will take time after the lesson and will try to draw these Venn diagrams. But I will take you to it right now. Come on, how do you plot probability of A?
We'll just shade the A region.
You just shade the A region. Okay. How do you plot A and B?
So the intersection of
Inter
A and B.
A or B?
So you're gonna take the union of A and B.
Not A.
Not A, so you would take everything except for A.
Neither A nor B.
Neither A nor B, so you would take everything except for A and B.
Neither A nor B. So I take everything except for A and B. Here. A or B minus A and B.
A or B minus A and
A
B,
or B is this.
which would give you everything except for the intersection and the outside box.
So A or B is this.
Yes.
From this, I am minusing this.
Yeah.
It will only be this part.
Yeah.
Tell me something about A and C over here.
Mutually exclusive events.
They are mutually exclusive events. Okay, I also want you to take some time and try to understand these Venn diagrams, but I'm not doing that right now with you. Tell me the difference between independent and mutually exclusive events.
Independent events do not have any intersection, but
No,
mutually
that's
exclusive.
mutually exclusive. Mutually exclusive events do not have anything in common.
Okay, give me example of independent.
For example,
Pin B
yeah,
can happen, A can happen independently, B can happen independently, A can also happen, and B can also happen. They have no connection with each other. So when the two events are independent, the probability of A and B is probability of A into probability of B. Okay, they can happen at the same time. It means tossing a coin and rolling a dice. These events are independent of each other. Okay, Mahad marrying, Haris marrying are independent of each other. Are you with me?
Yeah.
But when it is mutually exclusive, but when it is mutually exclusive, probability of A and B both happening together is zero. Okay,
Yeah.
when the event is mutually exclusive, probability of A and B both happening together is what? Zero. And what about probability of A or B? So when the events are mutually exclusive, either probability A can happen or B can happen. Or means plus and means multiply. First, understand this part. I'm pausing the video for a. When the events are independent, that means one happening, other happening, it does not matter. A and B can happen, probability of A into probability of B. Are you with me?
Yes.
Okay. When the events are mutually exclusive, that means Haris and Mahat cannot marry together. So probability of A and B happening together is zero. When the events are mutually exclusive, either A can happen or B can happen. Both happening together is zero. This is the only thing you have to memorize. Are you with me? If you
Yeah.
have to prove the events are independent, so what will you do? You will first find probability of A, okay? Then you will find probability of B. Then you will cross check. If probability of A into probability of B, it is equal to A and B, A intersection B, then it is independent. If probability of A into probability of B is equal to A intersection B, then it is independent. If it is not equal, then it is not independent. Are you with me?
Yeah.
Yes.
Okay. When the events are not independent, probability of A or B is what? Probability of A or B. It is probability of A plus probability of B minus probability of A intersection B. You should know this.
This is for not independent events, right?
Not independent event. In mutually exclusive, what happens? When the events are mutually exclusive, I say either A can happen or B can happen,
But they both can't happen at the same
but
time.
both can't happen together. That is why we say in mutually exclusive, probability of A union B is probability of A plus probability of B minus probability of A intersection B. But when they are mutually exclusive, this is zero. That is why this becomes our equation. So when events are mutually exclusive, A and B cannot happen together, and probability of A or B or A union B becomes only A plus B. Are you with me?
Yeah.
The general formula of probability of A union B is what?
The general formula is probability of A plus probability of B minus A intersection B.
And in case of mutually exclusive, this will become what? Zero.
This will become zero.
Okay, so there's a difference between independent event and mutually exclusive event. In case of independent event, A can happen and B can happen. That is why I multiply. In case of mutually exclusive event, A intersection B is zero. With me?
Yeah.
This is all I think for probability. Now I want you to practice the Venn diagram and then I take you to the tree diagram. Everything related to probability covered. There are a few Venn diagrams. Come on, Haris, explain me this. Everything in set A.
Everything in set A, which means that everything in set A is going to be the intersection and A itself. Yeah, that's it.
Everything not in set A.
Yeah, so everything but not in set A. So it's going to be the probability of B, but not the intersection, since the intersection also has the probability of A.
I just put
And
general
then,
language. A
okay,
would be full A, not A would be everything other than A.
yeah, okay,
That this is complement of A.
yeah.
Okay, fine. Mahat, A union B.
So you need to shade everything which is inside of A and B,
A union B also represents
A or B, A and A union B.
either A or B or both.
Yeah.
Okay. A union B, not.
So everything which is outside of A union B, you highlight.
Haris, A intersection B. It's very self-explanatory.
A intersection B, which is just what's between A and B.
A intersection B not.
A intersection B not, which means other than the intersection, everything.
Okay, fine. Haris,
Yeah.
explain me this.
So the A is A intersection B not,
Why?
since we take the intersection of A and B not. So that's it.
No, I didn't understand this. Explain me this properly.
So we're gonna take what's part of A but not does not intersect with B.
This is B.
Yeah,
B not is everything here.
yeah. And then we take what intersects with A and B not.
So A intersection B not is this part. Okay, fine. How do you
Yeah.
define this B part?
And B part. B part would be A B union A not.
How? Tell me how.
Since it includes everything which is not in A.
It includes
But
everything that
it
is not in A. So ये हुआ.
Yeah, but then there's B, so we're gonna shade the B part, and whatever intersects is gonna give us this.
So in intersection you only take the common part. But here
Yes,
we are taking everything. This is A naught
yeah.
and full B. So they are taking everything. When they are taking everything, it's like marriage. And marriage
So
is
it's union.
union. So it's A naught union B. Huh?
Yeah.
Okay. Then this is done. This is what?
This is gonna be, oh, this one is gonna be A intersection B intersection C.
This?
This one is gonna be A union B union C.
Yeah.
This one is gonna be A union B intersection C naught. So everything in A and B, but intersection of C naught. So
You
yeah.
have to remove that part. Mahat. This is already done. Okay, this is the same thing. So this is
Yeah.
all with probability. Now we had probability formula. Come on, before I go to probability formula, there is a diagram over here. Okay, tell me A naught. Tell me what all is there in A naught.
1, 3, 5,
A union B. Please,
2,
both of you.
3, 4, 5, 6.
Okay, one by one say. A intersection B.
2.
A intersection B naught.
A intersection
3,
B naught,
5.
right? So 4 and
Oh
6,
yeah,
yeah, 4
sorry.
and 6 naught.
4 and 6. Yeah.
Okay, A union B naught.
So anything outside of A and B, which is 1.
A intersection B naught.
So everything outside of the intersection, which is 1, 3, 5, 4, 6.
Fine. So when I'm talking about probability formula, give me the formula of A union B.
A union B is probability of A plus probability of B minus probability of A intersection B.
Okay, and if the events are independent, then
Independent, then probability of A intersection B would be 0.
is that an independent or is that a mutually?
That's mutually exclusive.
Sorry, that's, yeah, that's mutually exclusive.
Okay.
Independent would be this.
Probability of A or B if its events are mutually exclusive.
A or B, which is A union B.
Hmm.
Probability of A plus probability of B minus 0.
Huh?
You said mutually exclusive, right?
For mutually exclusive, it will be A plus B.
Yeah, so
Normal
when
formula for A union B is what?
probability of A plus probability of B minus probability of A intersection B.
This is also OR. Okay. Give me probability of A given that B has already happened.
It would be probability of A intersection B divided by probability of B.
Hmm. When events A and B are independent, okay, what is the probability of A? What is probability of A into probability of B?
When they are independent,
Hmm.
so they
Probability of A
equal to,
intersection B.
yeah, they equal to probability of A intersection B.
Okay. So this can be written in other ways also. A and B are independent. What does it mean? That A does not depend on B, B does not depend on A.
Yeah, they both could happen at the same time as well.
They both could happen at the same time. So probability of A intersection B can also be written as probability of A into probability of B given A has happened. Can it be written like this?
Hmm, no, I don't get this part.
A and B are independent of each other.
Yeah,
That means you write B or B given A has happened has it makes no difference because B is going to happen irrespective of the fact A has happened or not. B
I
given.
still do not understand this one.
Okay, listen to me. When A and B are independent, okay, A and B are
mhm.
independent. So I would say that probability of A happening and B happening are two separate things. Rolling a dice and tossing a coin are independent events. Say for example, probability A is rolling a dice, and probability of B is tossing a coin. So this can be written as probability of tossing a coin given that rolling a dice has already happened would still give you the same answer.
Yeah, because irrespective of the dice or the coin getting flipped, it would happen.
Yes. So when the events are independent, B has no connection with A. So probability of B or probability of B given that A has happened means the same.
Yeah, okay.
And probability of A or probability of A given that B has happened also means the same.
Yeah,
Are you with me?
yeah,
So when the events are independent, A or A given B has happened is the same thing. B or B given A has happened is the same thing. Are you with me?
yeah.
When events are mutually exclusive, what is the probability of A intersection B?
0.
Zero. When events are mutually exclusive, how would you draw the Venn diagram of A and B?
There, there would be no intersection and there would be just two circles.
There would be no intersection and they would be just two circles. Now, tree diagram. How can you explain this? Conditional probability. Either A can happen or A cannot happen. Come on. Okay. I have event A can happen or A cannot happen. B can happen, B cannot happen, B can happen, B cannot happen, C can happen, C cannot happen. These are some possibilities that is given to me. Can you tell me how do I find probability of C? What does this mean?
Probability of C would mean probability of A intersection B intersection.
A, B, C. Okay.
Yes.
Only this much?
No. There's gonna be there's gonna be multiple ways, which is gonna be one of them would be probability of A intersection B not intersection C.
One would be A, B, C plus A, B naught, C
Yeah.
plus
Plus A naught B naught C.
A naught, B, C
Yeah, I said that one. And
and
then
A naught, B naught, C. Mahad, are you with me?
yes.
Yes, miss.
Okay, Mahad, can you give me probability of B intersection C naught?
Yeah. So it's going to be probability of A into probability of B,
Hmm.
B naught
A into B.
into, yeah, sorry, B into C naught.
Okay. And
And then probability of A naught into probability of B into probability of C. And then we add them together.
not C, it would be C naught.
Yeah, C naught.
B intersection C naught, B intersection C naught. Probability of B happening. Haris.
Of B happening. So that would be probability of A into probability of B or probability of A naught into B.
Okay. Mahad. A naught intersection C.
So probability of A naught into probability of B into probability of C plus probability of A naught into probability of B naught into probability of C naught. Sorry,
Okay.
C. Yeah.
Haris, what was that example of the green and white? Do you remember?
You could make it. Like you could take 10 balls in total and give it
10
random
balls.
values.
Come on, give me
Yeah.
example. 5 green.
Uh,
No, I'll make it 6
uh,
green and 4 blue.
yeah, okay.
Okay. Then,
Then you make the tree diagram for either green or blue.
hmm,
Okay, so the first probability would be for green would be 6 by 10
hmm,
and blue would be 4 by 10.
okay. So this
Okay.
is the first pick.
Yeah.
Okay. This would be the first pick.
Yeah.
Second pick.
Yes. Second pick would be since you chose a green, so it's gonna become 5 by 9
Hmm.
and blue would become 4 by 9
So probability of getting a green green
is 6 by 10 into 5 by 9
and probability of getting a green blue.
is gonna be 6 by 10 into 4 by 9.
Okay. What about this?
Okay, for this, it would become 6 by 9 for green
Hmm.
and it would become 3 by 9 for blue.
Why you reduce one?
What do you mean? Why reduce one? Because we chose a blue.
Okay, fine. So probability of blue green would be how much?
4 by 10 into 6 by 9.
And probability of blue blue would be how much?
4 by 10 into 3 by 9.
I think this is all for probability.